Hi, good afternoon. My name is Elizabeth Capon, and I will do the presentation. Unfortunately, I am afraid that my Zoom app is blocking the camera. So unfortunately, I won't be able to share my camera. In any case, let me start sharing my screen, my presentation. Today, let me see. Can you see my screen? Can you see my screen? I hope so. Just a quick check. Quick check. Yeah, great. So let me start. I'm really sorry for the inconvenience, and I cannot show you my screen. It's a big pleasure to participate today in the SheStartup in this event and share with you a bit of my background and also my field of expertise. The presentation today, I have called it AI-based decision support systems for sustainable processes. I am currently a senior principal data scientist in PepsiCo, and I am optimization and simulation lead. Just let me introduce very quickly my company. PepsiCo is, you may know many of the products that we can see on the screen. And one of the purposes in PepsiCo is winning with purposes. And we have a set of values to become faster, stronger, and better, and provide this to all the people. So our lemma is smiles with every sip and every bit that we have, and the companies really pushing this all around the globe. We have an inspiring positive change for the planet and the people. So we have an initiative in the company which is called PepsiCo Positive. And we also have a foundation which is helping in many developing countries and all across the globe for many causes, for example, for empowering people to reach drinking water and so on. And let me introduce my current place of work. So PepsiCo is a global company, but we are, I am currently located in Barcelona. Fortunately, we have there our digital hub. And basically, it has been created last year. And there we hold a position globally where we are serving the company with data and analytics. And it's a corporate function. So in data and analytics, we are tackling several topics. We are handling analytics. We are using analytics to foster business. We are using data science. So we use data as our primary source of information for making informed decisions. And we manage all this information. And with these three main topics, we can build decision support systems. In this case, are applied to PepsiCo, but in general, these are the three main pillars for creating decision support systems in the industry. So why are we here? So basically, we are currently facing the fourth industrial revolution, in which we have cyber physical systems. So we have gone through different phases in our recent years, and now we have further information, and we have we're further empowered to make better decisions by more advanced and intelligent systems around us. Which are the design principles for these cyber physical systems? So first of all, interoperability, technical assistance, information transparency, and decentralized decisions. Let me give you a very brief overview of the presentation. I have structured, first of all, in the so-called topic enterprise-wide optimization. I will tackle what is structural and functional integration. Then I will present briefly the topic of knowledge management. These two topics are are some examples of AI-based systems or artificial intelligence topics that are used in the industry. And then I will give you some examples related to the waste to energy applications and the pharmaceutical industry. I will not disclose any topic or any project from my current position, because basically for confidentiality issues, and second, on the other hand, these two decision support systems that they will present have been published in scientific research and can be further explored beyond or after this conference in case you want to have a deeper look into these topics. And I will close with some final remarks. So what is the integration of decision levels? So in the industry, we have different decision levels. So from the more day-to-day decisions, so control of our processes, we go to the planning of the functions, so planning of the production plan, planning, and then the strategic design decisions of how we will locate our supply chains. So on the left-hand side, I mentioned the structural integration. So it is related to integrating the problem features into different levels. So for example, if I want to integrate the process itself, so the control of the process in a given reactor together with the scheduling, this would be the integration of control and scheduling. On the other hand, we have the so-called functional integration. It refers to integrating functionally different levels, and it means to reach decisions considering multiple objectives. So economic functions, environmental functions, safety functions, quality functions, reliability functions, and customer satisfaction. I hear, since this presentation is basically technical, I am here presenting some references. So basically here we had a polymerization of acrylic fibers plant, and there we had to integrate the control problem together with the scheduling problem. And basically we posed a mixed integer dynamic optimization problem in which our differential equations were discretized to be included as a set of linear equations in a mixed integer linear problem. So we transformed a mixed integer dynamic optimization problem into a mixed integer nonlinear problem. And basically, we used custom-made solvers in order to find the optimal solution. In this case, what basically happened is that in case we are able to integrate these two levels, we achieve a better operation from the control part and from the scheduling part. And all this work has been published in this reference. And if you later want to further refer to this, please contact me, and I will be very glad to share this information. What do we refer as functional integration? As I explained before, when we have multiple objectives. In this case, we have a multi-objective optimization with two objectives. We have in the x-axis would be one objective, which is here called mu1, and in the y-axis a mu2 objective. So basically, when we have two objectives, we have these so-called Pareto frontiers. And the objective is to optimize a given problem considering several objective functions, which usually are going in different ways. So for example, if I want to minimize my total cost, maybe I will be using a process which has a higher environmental impact. So maybe the best from a cost perspective is not the best from a environmental point of view, but this Pareto front, what gives us is a set of trade-offs. So maybe if I sacrifice a bit my gains, so my total cost. So if I have maybe a higher cost, or if I have a lower benefit, let's call it like this, maybe I can have also a lower environmental impact. So basically, this is what integration is about. In this case, I applied this functional integration also to the same problem as before, using a multi-objective genetic algorithm. So we are talking about optimization tools. And there were two parts. For the mixed integer nonlinear part, we used one solver, and for the mixed integer linear part, we used Cplex. And basically, we did a loop from the problem definition until we got the Pareto front. We used MATLAB to solve this problem, and also the different solvers. And at the end, what we had was three different objectives. We had environmental impact, profit, and make span, and we had in a three-dimensional space, we had the representation of our Pareto front. Regarding the functional integration, as I was presenting before, we also have some kind of decomposition techniques. And here I am presenting you the integration of the supply chain problem and scheduling problem. So we have here, you can see on the left-hand side of the screen, from the suppliers to the markets. And in case we want to optimize our supply chain, since this is a really complex problem involving many variables and many constraints, we tend to do decompositions. And this is on the left-hand side. On the right-hand side, I present a bit which is the approach, which is a Lagrangian decomposition. And for the sake of time, I'm sorry, I will not enter into the details. I have again the references. In case you want to go further, or maybe later in the Q&A, we can go deeper through the through one of these different case studies. But overall, from this first part, which is my conclusion, we can use optimization tools in many disciplines, first of all. And the second one is that we can integrate decisions that now are done not systematically. And with these tools, we can reach a better and informed decision about which is the set point of our processes, the amounts to be sent from one point in our supply chain to another point in our supply chain, and so on. A second topic related to AI that I wanted to share with you is knowledge management. Knowledge management is also referred to as semantic modeling, and there are many disciplines related to knowledge management. There is database technologies, decision support systems, that is the topic of our talk today, technical writing, artificial intelligence, web technologies, and this is basically where all this knowledge management comes from, and where it is also its main application is in the web. That we are using in our day-to-day. The good part of having semantic modeling is that we have explicit relationships. It allows flexible modeling. It has a consistent vocabulary. It allows to manage information and capture knowledge within organizations. And in this field, in my role in the academia, I was developing the so-called Enterprise Ontology project, which supports the management of different concepts along the enterprise structure, including the physical models, procedural models, recipe models, and different functions and processes. And it captures knowledge from the basic concepts to the rules that we may have in a given setup. And then we have instances of our ontology for a given problem. We integrate this with standards, so this way we can streamline processes, we can reach instrumentation and automation concepts at manufacturing level. It is the good part of using and adopting standards is that it can allow the practical application of the knowledge, and it can be shared among organizations, because among organizations and within the organization, because there are committees for the nomenclature, and it's a standard agreed by in the industry. my work, I have here again several references that can be checked afterwards. Basically, here I present a real system of a process industry, and there are different scales of knowledge management from the process itself, which is this called background, to an operations research ontology. So in this flowchart, basically, we explain how from a given problem instance, we can create a mathematical program based on this ontology for operations research. So these are applications of knowledge management into the industry. And last but not least, okay, Elizabeth, you can ask me, okay, all this is theoretical knowledge. How can we apply? Can you give us practical examples? And basically, we apply this for decision making. So we have usually abstractions of our systems. We need to analyze them, formalize that in a model, select a procedure to obtain the solution, and then go back to the system and validate that our solution is correct and implement it. So we need to validate the algorithms and need to validate the models at each of these steps, and then go to the real system. This is usually the decision-making process. So what about this application? So we have a given production site. It is from a real chemical plant that is producing chemical waste, which has a high amount of energy, which can be reused for other applications. So here we have an incinerator where we incinerate some of these liquid residues. Some others go to the wastewater treatment plant, and basically we use some of the steam that we generate in our incineration to go back to the production site, or we could even use it for households in the nearby regions. So basically what we did was defining the boundaries, understanding which is the process from our waste to flue gases and which are the different steps. And what we did was basically to set up an optimization problem. The motivation was to save energy. Basically, if we put into the incineration unit a mixture that it has not enough energy, then we need to put in natural gas. And if it has too much energy, then we need to put water. So the objective is to put the right amount of energy by means of our mixture of wastes. So we need to keep in this region. Everything that is below, in terms of mixture, we need to put additional natural gas. And everything that is below this limit, above this limit, needs water. So in theory, the average energy content of waste is sufficient for incineration, but the problem is how do we do these mixtures? Overall, the problem consisted of 50 to 100 waste streams per week. We had a problem with more than 30 production sites, intermediate storage tanks, and 19 lances where this waste was burned. And the problem there was that we had also to handle the uncertainty related with the forecasted quality and the amounts. I will very briefly present the results so that, let me go ahead. We basically put an integration, a structural integration from the operator to the planning model that included several weeks. And we had also to consider the blending problem. And basically what we could achieve, let me go quickly, and we may go back in the Q&A if you think it is necessary or if we have time. We achieved a 60% reduction in natural gas consumption along a whole year. So basically, here we applied an optimization problem, which was somehow quite big. It had between 6 and 13 millions of equations and millions of variables. It's in the order of magnitudes. In this order of magnitudes. We also created a black box allocation model for the incineration process using MATLAB and also AspenTech simulation software, which is specific for this chemical engineer point of view. And yes, basically, we also did network optimization. So we did also the supply chain optimization for a network of waste treatment units. Let me go to the second example because we are running out of time and I don't want to extend my presentation. The second application is the drug manufacturing process. As you may imagine, it's an extremely elaborate process in which we can also benefit in the pharmaceutical industry from resource utilization and point of view, and also to reduce the quality costs. And basically what I did in the past was a rigorous approach to scheduling the drug product manufacturing, and a data-driven tiered procedure for enhancing the yield in drug product manufacturing. Basically what we could do by improving the resource utilization and improving the quality costs, in terms of scheduling, we've used an optimization-based production planning, and what we could reach was a 50% reduction of the late orders. You may imagine this was a production plant of parenterals, so it was they were critical drugs, and everything that was not produced on time was affecting directly to the patient. So reducing the amount of late orders first improved the performance of the plant, but also was having an impact on the person, on the patient. A second approach was the improvement of a lyophilization process. So basically there, this is related to reducing the time or tuning the time that for a given recipe. And basically what we could do was to optimize the recipe compared to our standard, using some sensors, some first principle modeling systems, and also including optimization techniques. And basically the point there was to be able to know exactly when the chemical, the drug was correctly lyophilized. I have gone very quickly. Maybe in the Q&A we can go back. Let me give you some final remarks and some points for this decision support system. So we need, first of all, to give answer to the current needs of our society, and with these advanced decision support systems, we can reach this. Or we can give answer to our needs. There are many topics I have presented. Knowledge management for improving interoperability and information transparency in this context of the Industry 4.0. And I have also presented optimization-based techniques. There are other artificial intelligence-based techniques, but basically what we can provide us as decision makers in the industry is technical assistance and also support decentralized solutions. And with this, I'd like to thank you for your time and for your attention. I'm sorry from the camera, and I will be glad to answer your questions.
Elizabeth, that was amazing. Can you hear me properly?
Yes, I can hear you.
Fantastic. Thank you so much. And oh my God, the things that you guys are working on, unbelievable. So here we have a couple of minutes for questions, and I already have one for you that one of our ladies here is asking. Eva, she says that AI is such a hot field. Are people having trouble finding talent? So we're more on your personal experience and belief regarding your field, let's say.
Yes. So the question is about, can you repeat, Anna? So the question is about?
Yes, if people are having trouble finding talent in the AI field.
Yes, of course, it's a completely new topic. You can imagine when we were 6, 7. So now I have children who are 6 or 7. When I think, okay, when I was 6, 7, could I ever imagine that I would be working with computers, developing models in a computer? To tell you the truth, I didn't see a computer until I was 10. So imagine, it was not even imaginable from that point of view. So of course it is difficult. It's a new topic, but step by step, universities and people are gaining consciousness about it, and really are taking action, because at the end this is somehow our future.
Totally agree. Okay, so here I have like a little bit of praise for you. People saying that it was a great introduction and very interesting. A lot of people saying like what a big impact, okay, is all this making. Here I have another one. I have two questions actually. What would be the first step in improving knowledge management systems for a company?
Yeah. Oopala. So first of all, the very first step for a company is to hire a person with knowledge management background. So it is not easy to find a person with semantic technologies. It's a very novel field, number one. But number two, the first thing that you need to do is to set up your boundaries, to establish the processes and the knowledge that you want to formalize in this model, because knowledge management at the end is about formalizing your processes in a knowledge model, and then using this knowledge model to grow based on the processes of themselves, of your industry, so on data, and combining these with analytics. So the first point is set up your boundaries and establish your processes.
That was fantastic, because you actually answered the follow-up question that was actually saying, what would you recommend as a first priority?
Yes, exactly. Is formalize the processes and understand what knowledge management is about semantic modeling, understanding which are the available tools, the necessary, the processes and the methods there. Perfect. And that it per se is not an enabler. It's the basis for then, on top of that, using these AI tools. So it's a first step for opening the processes to a wide range of disciplines and a wide range of tools that can improve the processes.
Wow, perfect. Okay, so we still have you for like just a few minutes. So if anybody else has another question, I think this is your moment before she leaves. Let's see. And I don't know, same for you, actually, Elizabeth, if there's something, I don't know, that you would just like to let.
Yeah, if you want to, I can share my links, the links to the different papers, and also the link to the company. So where I am working now in PepsiCo. So I am extremely happy to be able in such a company that is so open and with so open and really doing innovation and providing this set of tools and hiring people in these fields.
I see. And actually, we have someone asking as well. Sambra is asking, the introduction, of course, was very interesting. And just wanted to know, what kind of openings do you have? Are they for the product engineers or software engineers? And as you said, there are so many positions open. And actually, Sambra, if you go to PepsiCo's booth, actually, you will be able to talk with people from the company. And exactly. Through our job board, we have PepsiCo's openings as well. And of course, you guys have your website, which is global, and people have it there in your booth as well, so they can access and check all the openings that you have around the world.
Yes, thank you, Anna. Yeah.
So yeah, what more can I say? To be honest, I'm very grateful to have had you here. Thank you so much for being part of SheStartup. And
thank you, y'all.
Hope to cross your path
for this opportunity. Thanks.
Thank you so much.
Very much.
Have a wonderful day.
Thanks, you too.